All right, we get chapter number 7, problem number 37, and it reads, a frictionless pulley, which can be modeled as a 0.8 kilogram solid cylinder with a radius of 0.3 meters, has a rope going over it, as shown in figure P7.37. The tension in the rope is 10 newtons on one side and 12 on the other. What is the angular acceleration of the pulley? All right, so this is a torque problem, so we're going to go with Newton's second law version of the rotational kind, which says that the torque is going to be equal, excuse me, I wrote the wrong part there, I alpha, and we're talking about the net torque, so we're going to have to find out what is the net torque between the 10 and the 12 Newton forces. So to do that, I've set up this little icon here that says that any force that's going to cause the pulley to rotate in the counterclockwise direction is going to be positive, so we can say then that the 12 Newton force will be positive and then 10 Newton force is going to be negative. So we would have F12R minus F sub 10R is equal to I alpha. And when we get that, we can say that we've got 12 times 0.3 minus 10 times 0.3. And that's equal to I times alpha. The problem is we don't have I, the moment of inertia. We need to find that. So what we can normally do, if it's just a solid cylinder, we can look up the equation for the moment of inertia of a solid cylinder, and it is 1/2 mr squared. So plugging that in, 1/2, and then m is 0.8, r is 0.3, and that's going to get squared. So the moment of inertia for this cylinder is going to be 0.036 kilogram meters squared. So we can plug that in over here, 0.036 times alpha. And we do the math, we solve for alpha, and we get 16.67 radians per second squared. That is problem number 37 for chapter 7.